Okay, these are the activities for 6.1. Compute the Laplace transform of y of t equals 1. So the Laplace transform is the integral from 0 to infinity of y of t times e to the negative st dt. In this case, y of t is 1. So this is just the integral from 0 to infinity of e to the negative st dt, which is e to the negative st over negative s evaluated from 0 to infinity. When you put infinity in, this fraction, the numerator of this fraction is exponential decay. It will go to 0. And when you put 0 in, you get e to the 0, which is 1. So 1 over negative s, and this becomes 1 over s. Okay, the Laplace transform of y of t equals t. So that's the integral from 0 to infinity. Replace the y of t with a t. So I have t e to the negative st dt. That is going to be a by parts problem. So I'm going to let u be t and dv be e to the negative st dt. So that means du equals dt and v equals e to the negative st over negative s. And then my integral is going to be u times v minus the integral of v du. U times v is negative t e to the negative st over s. That's u times v minus the integral of v times du, which is, make that a plus, and I get e to the negative st over s dt. Now this has to evaluate from 0 to infinity, and this goes from 0 to infinity. So for this numerator, when t goes towards infinity, this goes to infinity, but this term goes to 0, and it goes to 0 much faster because it's exponential decay versus linear. So that's going to go to 0. And then when you plug in 0 for t, you also get 0. And then the integral of e to the negative st dt is, and it's all over s. So this is going to be e to the negative st over negative s squared, evaluated from 0 to infinity. And when you go put infinity in for t, that's exponential decay, so it's going to go to 0. And when you plug in 0, you're going to get 1 over negative s squared. So we get 1 over s squared. Okay, the inverse Laplace transform for 4 over s times s plus 3. So I'm going to have to use partial fractions. So I want 4 over s times s plus 3 to be rewritten as a over s plus b over s plus 3. This becomes 4 equals a times s plus 3 plus b times s. I get that by multiplying both sides by the common denominator. And I'm going to plug in some easy values for s. So if I plug in negative 3 for s, I get 4 equals negative 3b. So b is negative 4/3. And if I plug in 0 for s, I get 4 equals 3a. And a is positive 4/3. So I want to take the inverse Laplace transform of 4 over s times s plus 3. That is the same thing as the inverse Laplace transform of 4/3 over s minus 4/3 over s plus 3, which is 4/3 times the inverse Laplace of s minus 4/3 times the inverse Laplace, oops, that's 1 over s, and this is 1 over s plus 3. Okay, so to finish this up, we know that the inverse Laplace of 1 over s is 1, because we just did that on the last page. So this is 4/3 times 1 minus 4/3 times the inverse Laplace of 1 over s plus 3 is e to the negative 3t. So this is 4/3 minus 4/3 e to the negative 3t. Okay, one more. So I want to solve the initial value problem, y prime plus 5y equals e to the negative t, with an initial value y of 0 equals 2. So you start by taking the Laplace of both sides. We're going to use properties of Laplace transforms. So this is the Laplace of y prime plus 5 times the Laplace of y equals the Laplace of e to the negative t is one over s plus 1. Okay, and the Laplace of y prime is s Laplace of y minus y of 0 plus 5 Laplace of y equals 1 over s plus 1. And y of 0 we know is 2. So I'm going to go ahead and put that in as a 2. Okay, so I want to gather all my Laplace of y's together, and anything that does not have a Laplace of y I'm going to put on the right. So this is going to be Laplace of y times s plus 5 equals 2 plus 1 over s plus 1. I want to get Laplace of y by itself, so I'm going to divide both sides by s plus 5. So I get the Laplace of y is going to be 2 over s plus 5 plus 1 over s plus 1 times s plus 5. And then y is going to be the inverse Laplace of 2 over s plus 5 plus 1 over s plus 1 times s plus 5. And this inverse Laplace is pretty straightforward. That's going to be 2e to the negative 5t. And then the next one, I'm going to have to do partial fractions to break it up. So I will do that on a new slide. This is going to be 2 times the inverse Laplace of 1 over s plus 5 plus the inverse Laplace of 1/4 over s plus 1 plus negative 1/4 over s plus 5. Okay, so to finish this off, the inverse Laplace of 1 over s plus 5 is e to the negative 5t. So this is 2e to the negative 5t. And then here, the 1/4 is going to come out, so I have plus 1/4 e to the negative t, and then minus 1/4 e to the negative 5t. Got some like terms here. 2 is 8/4 minus 1/4 is 7/4 e to the negative 5t plus 1/4 e to the negative t. So to break this up into partial fractions, I want to rewrite this as a over s plus 1 plus b over s plus 5. Multiply both sides by the common denominator, and you get 1 equals a times s plus 5 plus b times s plus 1. This has to be true for all values of s, so if s is negative 5, I get 1 equals negative 5 plus 1 is negative 4b, and b is negative 1/4. If s is negative 1, I get 1 equals negative 4a plus 0b, so a is 1/4. So I have 1/4 for a, negative 1/4 for b. Go back over here.